So if we want to assign number to the prefixes, we are going to do what? We are going to count from where we have the functional unit, which is this double bond, to favor this double bond. We count in a way that this double bond is going to have the lowest number if we start counting. So if we start from here, if we count from here, we are going to get 1. Okay, 1. And we have the double bond. If we start from here, 1, 2 is going to be 2, which is longer. So we use the shorter one, 1. All right. So what do we have here? We have 1 chloro, comma, 1 chloro. Then we continue. 1, 2, 3. 1 chloro, 3 bromo, 3 bromo. Okay. So what are we going to do? Since we now have everything, we have to arrange it. Remember, alphabetical order. C, we are still working on the prefix. C and B, which comes first alphabetically? It's B now. A, B, C. Okay, B. So we are going to do 3 bromo. Okay, comma. The next is what? C, which is what? 1 chloro, comma. Then what is the what? The parents, the parent's name or the parent chain is hex. Okay, so because it's a circular compound, okay, it's a circular compound, we are not going to put it cyclo. We are going to indicate it, okay, cyclo, hex. Okay, then this one, the suffix, that's the ending, in. So the name of this compound is 3 bromo 1 chloro cyclohexene. All right. Moving over to the next question we have here. Our next question is question 7. I was actually doing this question 7 when I got my resources depleted. Okay, memory no come again. So maybe we continue. Okay, so this structure is the structure of benzene. Okay, you know benzene is a cyclo compound. Okay, and it's what? It is hexagonal. Okay, the structure of benzene. Okay, how do you know where to put the double bond? You know that benzene has equal single and double bond. It has 3 single bonds and it has 3 double bonds. All right, so everything is equal in benzene. All right, so how do you put them? It is believed that the double bonds found in benzene continuously move around this hexagon. Okay, it continues to move. Okay, so you might see it here in this diagram, another diagram you see, and another diagram. All you have to do when you are inserting the double bond, just indicate it, say what you are going to do. Okay, just put one, avoid the other one, put another one, avoid the other one, put another one, just like that. You can put it in any location. Okay, it's important for you to quickly identify benzene when you see benzene. All right, there's another structure like this called ester. Okay, you see ester. Benzene can also be identified like this. The diagram of benzene, you can also see it like this. It's also benzene. Okay, we just put, because it's a cyclo compound, we just put circle inside like this. Okay, this is benzene. This is also benzene. Okay, so you know other benzene derivatives like toluene, xylene, benzanoic acid, phenylbenzene, and so on and so forth. All right, so let's look at this compound. For example, they give you this compound, they say you should name it. Okay, in your Jamb UTME, then they set and well. Okay, something like this. They give you a hexagon. Everything are waiting. Single bond. They come attach something like CH3 here. Okay, they ask you to name this compound. What are you going to do? It's very easy. First of all, let's find the prefix. Okay, count the what? The parent chain. Okay, the longest continuous carbon to carbon bond. 1, 2, 3, 4, 5, 6. We have 6 there now. That 6 is what? Hex. PC equal to hex. Okay, what next? We are going to do what? We check if we have a functional group. Do we have a functional group? No. Do we have double bond or triple bond? No. But we have a substituent. This is our substituent. And this substituent that we have here is called what? Let's put it sub. Is equal to what? Is equal to methyl. Okay. This is a methyl substituent. Okay. What else do we have here? It's now time to count so that we can create our prefix. But before we number, we have to note that this is a cyclo compound. So we indicate it there is cyclo. All right. It's cyclo. All right, so if we want to number, we are going to number to favor the substituent because it's only substituent we have there. So we'll number to favor the substituent. So we number in such a way that the substituent will have the lowest number. So we start from here. 1, can you see? 1, which is what? 1. Okay, that's where we have the substituent to favor the substituent. Okay, if you count from here now, it will be 1, 2. Or you count like this 1, 2, 3. No. You are not favoring the substituent. So we will now put it 1 methyl. Look at it. The substituent methyl. Hexane. Okay. Hexane. Okay, so we don't have the prefix yet. How are we going to identify the prefix? Is it a double bond? Is it a single bond? Is it a triple bond? So it's a single bond, no double bond here. So we are going to use in as the what? As the word suffix. Okay, suffix is in. Okay, so we are going to use in. This question A that we are looking at, what is the question we have there? All right, we have something like this. Then we have CH3 here. Okay, can you see? This is what we are asked to name this compound. All right, very easy. All we have to do, we come down here. Okay, we come down here. Let's leave this space for the naming. Okay, let's leave this space. We are going to put the name here. Okay, so first thing is to what? To identify the longest continuous carbon chain, which is the what? The parent chain. PC is what? The PC is what? Let's count together. Longest continuous carbon to carbon bond chain. 1, 2, 3, 4. That's what? 4. And 4 is what? The prefix of 4, ligands, is what? Is boot. Okay, boot. That's 4. Okay, so what are we to do next? Let's find the suffix, since we have the prefix. So suffix is what? What is it going to end with? Do we have double bond here? No. Do we have functional group here? Yes, we have a functional group. OH, which is what? The or. Okay, so the suffix with the or. Or. We end in or. So what next do we find? We are going to do what? We find if there is a substituent here. Do we have a substituent here? Yes. We have a substituent, and the substituent is CH3. Methyl. CH3 is methyl. So our sub is what? Is methyl. Methyl. Alright? What's next? Time to count so that we can assign number to the substituent or the functional group. Alright? So how are we going to count? Remember, the hierarchy says favor functional group, followed by double bond or triple bond, then followed by substituent. So substituent will be last. So if we want to number, we'll start numbering from this side. Okay? We start numbering from this side. Okay? To favor the what? The functional group. If we number from here, 1, 2, can you see? The functional group is having 2. Okay? And that 2 that is having, it shows that it's 2. But if we number from here, 1, 2, 3, the functional group OH will not be having 3. So we have to number from here so that we have the lowest number. Okay, so if we number from here, we are now going to have 2 all. That's what we are going to have. Let me just put it. 2 all. That's what we have. Then 1, 2, 3. 3 methyl. Okay, 1, 2, 3. Okay, 3 methyl. 3 methyl. Can you see? This is the methyl. 1 methyl and if not 2, you do the methyl. Alright? So for us to arrange this, we have to put it in alphabetical order. O and M, which one come first? Now M now methyl. Alright? So to put everything in alphabetical order, we are now going to say we start from methyl. M comes first. 3 methyl. 3 methyl. Comma. Boot. Look at it. We bring our parent's name. Boot, parent chain. Boot. How many? 2 all. Look at it. 1, 2. 2 all. Shikina. This is the what? The name of this organic compound. Okay? 3 methyl boots 2 all. Very easy. Okay, very easy. Let's move over to the next Jamb question we have here. The next Jamb pass question we have here is question 9. I think we have 13. Okay, question 9. We are scheduled for 13. Okay, question 9. What's in question 9? Question 9 is something like this. We have a central C here. Okay, then you have this one bonded to CH3. Okay, so how are we going to name this one? How are we going to name it? We go straight to the point. Straight to the point. Okay, first of all, we put our what? We find our longest continuous carbon to carbon chain, which is what? The parent chain, PC, is equal to what? We count 1, 2, 3, 4. Continuous chain, 5. And 5 is what? Pent. That's the what? The prefix. Okay? So the next thing to do is, do we have any functional group? Yes. Yeah. Yes. We have a functional group called the own. Own is the functional group. Remember, when you have a functional group, the functional group automatically becomes the suffix. Okay? The functional group is own. Okay? Look at it. Own. When carbon is bonded, double bond to oxygen, is what? The functional group own. Okay? Own, which is the what? The ketones. Alright? So, do we have any other thing here? Do we have a substituent? Yes, we have. We have CH3. Methyl. Okay? So, equal to what? Methyl. Okay? So, since we have 3 of these, what do we have to do? We start numbering so that we can assign number to the suffix and the prefix too. Alright? So, how do we number? We number in a way. Remember, functional group first. Favor functional group first before any other thing. So, if you number from here, 1, 2, 3, functional group go carry 3. But if I number from here, 1, 2, 3, functional group go still carry 3. So now the same thing. So we go take anyone. So we go say 3 own. Okay, 3 own. Okay. Which other thing again? We are now going to do what? We number for the what? The substituent. 1. If we number from this side, 1, 2. Remember, it's this side that we are numbering from, because we are numbering to favor this one. So all the numbering we will go do now from this side. So 1, 2. Now for the second carbon this thing, so we will put 2 methyl. 2 methyl. So if we rearrange everything together, ensuring that everything is in alphabetical order, we are now going to have what? 2 methyl, 2 methyl, what? 2 methyl, pent, bring it down, pent what? What's the own? 3 own, pent, 3 own. So this is the name of this organic compound. as easy as ABCD. Very, very easy. Question 10. Question 10. So what do we have in question 10? They say we should name this what? This compound here. So the first thing we do is, following the basic rule, we find the what? The longest continuous chain, which is the what? The parent chain. And if we count, how do we count? The longest continuous carbon to carbon chain. We are going to count from here. 1, 2, 3, 4, 5, 6, 7, 8. Can you see? 8. Look, oh, this one is CH2 and it has 3 here. It means that what we have here times 3. So it's telling us that we have 3 carbon to carbon bond here. Okay, so we are, this one here is part of it. Is part of the continuous chain. Can you see? Because this one is C3H7. 1, 2, 3. 1, 2, 3. 3 here. 4, 5, 6, 7. This one is 3. 8. That's 8. That will give us what? Oct. Right? Oct. So the prefix is oct. Alright? So what next are we doing? We identify if we have any functional group. Do we have any functional group here? No. We don't have functional group. But rather, we have a name. This N will also be the suffix. Okay? Suffix. Okay? The N is the suffix. Okay? So what are we looking at for here again? We are also going to look at if we have a substituent. Do we have a substituent? Yes, this is the substituent we have here. This one here is a substituent. Okay? C2H5. And C2H5 is what? Ethyl. I tell you, say when they lose one hydrogen atom, they become ethyl. Okay? If ethane loses one hydrogen atom, it becomes what? Ethyl. So the sub is now what? Equal to ethyl. Okay? Ethyl. 2 carbon atom, 8. The hydrogen atom, 5. That makes it I. So what do we do next? We arrange everything, we bring everything together. And we start numbering for the what? For the prefix. And when we are numbering, we number in a way that it's going to favor what? It's going to favor the, you know, the substituent. This is the substituent. Okay? This is the substituent. Alright? So we are going to number to favor this substituent. So if we number from here, for example, 1, 2, 3, 4, 5. Yeah? So we have 5 carbon to carbon atom to the substituent. Okay? Then if we number from here, 1, 2, 3, 4. So we have 4 to the substituent. Which one you think we will pick? We will do the 4 now. So we will number from here. So we number here 1, 2, 3, 4. Okay? 4 carbon atom to the substituent. So we are now going to have 4 ethyl. 4 ethyl. Okay? 4 ethyl. Then what's the parent's name? The parent's name is oct. And what is the suffix? A. So the name of this compound is 4 ethyl oct. Octane. Octane. As simple as ABCD. I will make it so simple. I will make it so simple. Alright? So I think we have about 3 more left. Right? Question 11. What we have here, they said we should name this compound. And the first thing to do here is to what? Count the longest continuous carbon to carbon chain. That's 1, 2, 3, 4. That's 4. So the parent's name, PC, or the parent chain will be equal to what? 4. 4 is what? Bute. Okay? Bute. Alright? So what next? Do we have a functional group here? Yes, we have a functional group, which is the OH. Sometimes they put on HO. Now OHO, they just confuse you. So FG, which is functional group, equal to OH. OH is what? The all. Okay? Do we have a suffix? Yes, single bond. Single bond hydrocarbon is known as